For this test, I'm not changing the spark gap at all. I'm just changing the angle of the camera. Putting on my clock, turning on my supply. So from this angle, you actually can see the third terminal spark gap, which is the little spark in the top left. So the main spark gap is the larger discharge you see in the center, between the two larger copper rods, and then the third terminal, once again, is about 1 millimeter or so from the top of the main two terminals. So it's closer to one terminal than the other terminal. There's no arcing going on directly between the two main terminals and the third terminal. There's only arcing going on between the top main terminal and the third terminal. The bottom terminal is arcing directly to the other main, the top terminal. I'll let this run for about a minute or so. Once again, the main distance between the two main spark gaps is about 3 to 4 millimeters, and the distance between the top terminal and the third terminal is about 1 millimeter. Once again, these are all kind of estimates, just roughly eyeballing. The third terminal there is grounded to earth, and in the camera it's the black wire that's by itself going off to the top left. The wires that are wound up upon themselves, the red and black wires in the foreground, are the sense inductor, which is going to another circuit. The two white wires, well, the one in the extreme foreground and the one way in the back, which is a little hard to see, is what's providing the main source of the voltage discharge. That's coming from the DC to AC inverter that I've made, which is that loud buzzing in the background. The discharge itself has a buzzing itself. That noisy inverter, and noisy as in electronically, it's also noisy as in, well, it makes a lot of sound, is then set up through a bunch of transformers, approximately 1 to 20. Now that's actually technically not enough to get a discharge at this distance, because I'm literally going from about 40 volts to 800 volts. So, and it takes about 3,000 volts to break about 1 millimeter. So, what's going on here is that the inverter that I've made also generates high voltage spikes, on the order of a few hundred volts actually. So actually what's being discharged is the amplified high voltage spikes. Now the other thing is the two main terminals are not actually connected to ground by any means, so they're actually floating. They're allowed to go to any voltage that they want. So because they're floating, this allows the third terminal to ground to actually be relatively low enough that it actually causes discharge across from the top main terminal to the third terminal. So I've let this test run long enough. I'm going to do another test without the third terminal.